I don't think I got everybody here. Who am I missing? I don't have a Jennifer out there. Got Alyssa here. I don't have a William out there. I don't have sister number 1 and 2. I know there's a lot of A's. Nope. Sister 1 and 2 are gone.
I'm here.
Oh, sister number 2. Where's sister number 1?
I was born first.
Where's Elena? What'd you say?
Right there.
There's a pop. There she popped in. All right, Elena, how are you doing?
Good. How are you?
I am doing good. So it's a Wednesday, so we're getting halfway through this, fun week here so far. Been kind of a chaotic week, but we're managing. So I'm gonna try not to make it too terrible for you guys today. I only made, I think, 3 icons cry last hour, so that was good. And it was all the Algebra 2 stuff that I told them. You remember how to do this? And they just looked at me. Well, it wasn't the icons looked at me, but I could tell the ones that were in class were like, oh my goodness. Yeah, that Algebra 2 stuff keeps on coming back. Okay, but I am going to review a little bit with you some sine and cosine sum and difference rules, and then I get to teach, the wonderful sum and difference of tangent rules, and then show you how we're going to apply all these identities, we're going to apply them with solving equations. So yes, we go back to that same thing that we did a couple of units back when we did the arc functions solving. We're going to do that some fun stuff. Okay, and then finally, we are hopefully get a good 40 minutes, to work on our worksheet there, the sum and difference worksheet number 2. And if you have any questions on the first 2 worksheets that we did, that would be your time during work time to go about asking those things. All right. Any questions here about our agenda? All right. So this is where, I always tell you, all right, I need you to find a partner right now, and I need you to pair share with them what the sum and difference rules are for sine and cosine. We don't have any partners. So I guess you're going to tell your dog or your cat or your Barbie doll. Or you're going to tell me. Or how about we just do this? Instead of you talking to people right now in your bedroom and your parents thinking you're more crazy than you really are, how about you just right now think about it? What is the sum rule for cosine? You can talk it out loud if you want. What's the difference rule for cosine? Now for sine. What was the rule for sine? And what's the sum rule for sine? Now, I'm going to skip the quiz, here, because for number 1, I skipped that question right there. Number 3, we've already done number 3, in our notes. And number 4, I think we've done something very similar to number 4 in our notes. But I do want to show you on number 2, why have I been doing all of these problems right over here? Because a problem like this, you should be able to go up here and solve and get an answer for without using your calculator and finding out, oh yeah, what's the sine of 56? What's the cosine of 34? Because right away, you should see that it goes sine, cosine, cosine, sine. So we know that this is a sine rule of A or B. But is it a sum rule or is it a difference rule? Remember if that's a sum rule or a difference rule? And why did you say difference? Because it's a plus sign. And I'm gonna say signs are the same. Okay, sine same, cosine's different. Okay, I think I have all of them written down here on my notes. Okay, right. Okay, on this slide right here. Okay, so if we're reviewing, okay, all of the rules, okay, right here. Okay, there's all the rules. Okay, that I have. And sine, you can see right here, if it's a plus right there. Sine same. Now, the one thing that we do gotta know is cosine was cosine, cosine, sine, sine. But if this is a plus, then it's a minus. If this is a minus, then it's a plus. Okay, the same thing down here. If we have a minus here, it's a minus right there. Okay, it goes sine, cosine. I just gotta flip these around. I got the B in the air around there, but then I do cosine, sine. Okay, so no one knows, okay, is gonna be, okay, rather important, okay, to do. Now, when we're looking at, okay, this problem right over here, okay, that we have, okay, that I was gonna give on the quiz, like we said, if that's a plus right there. So this ends up simplifying to sine of 56 and 34, because that's the sine rule, and then we have to, since that was a plus right there, add them together. And the sine of 56 plus 34 is now 90 degrees, and the sine of 90 degrees, that is, well, that's a quadrantal, and I hope you have these memorized, okay? If you don't have them memorized, that's one thing that you kind of want to have by the time you get to calculus next year, okay? Or whenever you take calculus, or okay, if you ever take calculus. Okay? Sine is vertical over terminal. I'm vertically going +1. I'm terminally going 1. So there's the answer to this problem. That whole thing right there simplifies, and that's what I had written down right here for my work. That whole thing that is simplifies, and I use the sum rule there. I didn't do something different. Okay, it simplifies down to 1. Okay, for your answer. Okay, any questions there on that problem? All right. So, with that being said, let's do a problem here that uses the sum and difference rule to find the exact value, but this time it's in radians. Okay, so go ahead and add this one right here to your notes from the other day. We have to find out what is the exact value for the cosine of 5 pi 12ths. Now, the bad part about this is some of us aren't so good at fractions. And the second bad part about it is some of us still avoid radians. I do not want you to change that to degrees right now. We weren't allowed to do that when we were doing cosine of pi thirds. No, you didn't change the cosine of pi thirds to 60 and then find out the cosine of 60 degrees. You had to memorize, okay, your ratios in radians. We're going to do the same thing that we did for degrees. Okay? We're going to make a little chart right over here. Okay, remember we did this in degrees. We had 30, 60, and 45 over here, and then we had, okay, over here we had 150, we had 120, we had 135, and then down here we had 210, 225, and 240, and then over here we had 300, 330, and 315. Then we were able to add and subtract numbers together. We're going to change this though now. We are not, okay, going to do any of this in degrees. Right? But instead, we're going to come over here and we're going to do it in radians. 30 degrees is the same as pi 6. We got pi thirds, okay, and we have pi fourths. Now, you might want to write this little chart down because this little chart that I'm going to have is going to help you as you continue, okay, to find exact values of radians amounts. Okay, you remember all those problems that were on yesterday's worksheet that I said, oh, don't do these yet? Well, this is how you would have done them. Well, what is the amount of pi 6. So what is pi 6 over here in quadrant 2? Well, that means I'm pi 6 shy of 6 pi 6. So if I'm pi 6 shy of it, this is really 5 pi 6. And that's the same as 150, I know. And now, pi thirds. Okay, what is pi thirds in quadrant 2? Well, this is really 3 pi thirds, so I'm pi thirds shy, which is 2 pi thirds. And how about pi fourths? Well, this is 4 pi fourths, and if I'm pi fourths shy, this is 3 pi fourths. And I continue to make those same ratios or those same things in quadrant 3 and 4. Okay, if I go by 6 pi 6 by pi 6, that's 7 pi 6. If I go by 1 pi thirds, okay, from 3 pi thirds, I'm at 4 pi thirds. And if I go by a fourth of a pi from 4 pi fourths, 5 pi fourths, if I'm by a fourth of a pi, be at pi. Okay, then the last quadrant, okay, I know that this right over here is 12 pi 6. So in this quadrant, we're at 11 pi 6. In thirds, this is 6 pi thirds. So if I'm a pi thirds shy, this is going to be 5 pi thirds. Okay, and then if I'm in quadrant 4 and I'm in fourths, so this is 8 pi fourths. Okay, this little answer right over here is a pi fourths shy, which is 7 pi fourths. So my question that I have for you right over here is, how do I add these numbers together to get 5 pi 12ths? The bad part is they're all in fractions now. And fractions need common denominators to see what you can add and subtract together. In order to add these together, okay, pi 6 is the same as, and again, I'm trying to get them into 12ths so I can see what we'll add together. Okay, pi 6 is 2 pi 12ths. Pi thirds, I'm going to multiply here by 4 over 4. That's 4 pi 12ths. And pi fourths, which is 3 pi 12ths. So I've converted these things right here so they are equivalent. And notice I have to get 5 pi 12ths. 2 pi 12ths and 3 pi 12ths add up to 5 pi 12ths. So that's what I'm going to write over here. Cosine of 3 pi 12ths plus 2 pi 12ths. So I'm going to use the sum rule. I could use the difference rule if I wanted, but I would have had to come over here and change this right here to 10 pi 12ths. I would have had to change this right here to 8 pi 12ths. I would have to change this right here to 9 pi 12ths. And I would have had to see, what can I subtract? Okay, well, I could have subtracted, okay, right here, 9 pi 12ths. Okay, and the 4 pi 12ths, that gives me 5 pi 12ths. But I'm going to use the sum rule right here. And the sum rule goes like this. Cosine, okay, of 3 pi 12ths. Cosine 2 pi 12ths. Sine 3 pi 12ths. Sine 2 pi 12ths. And if this is a plus, second time's the charm, Melissa.
Subtraction.
You got it. Okay, if that's a plus, sine same, cosine not the same, they're opposite. Okay, so if that's a plus, that's a minus right there. Now, the only bad part is some of you don't even know what the cosine of pi fourths is. let alone what it is if it's not simplified. So I'm gonna simplify this down to 3 pi 12ths. I'm gonna write it back down to pi fourths. Because I know pi fourths. Okay, if I'm doing pi fourths, okay, again, you should not have to do this, but pi fourths is a 1, 1 square root of 2 triangle. So pi fourths is 1 over square root of 2. Okay, we have 2 pi 12ths. That simplifies down to cosine of pi 6. And cosine of pi 6. Then again, we're going to draw a reference triangle down. Now you should, again, be able to figure this out without drawing this out. And when I say that, by the time you get to calculus, this has to be second nature. You've got to be able to look at these ratios and know them off the top of your head. It's kind of like some of us, when we add and subtract numbers, and even multiply numbers, some of us still type it into our calculator. 5 plus 3, enter. Homework takes forever if you have to use that calculator every time. We should be able to look up here and say, oh yeah, okay, I got to do cosine of this. Okay, that's going to be the square root of 3, 1, and 2, and cosine's 1/2. Oops. Okay, now, next part, subtract. Cosine. Cosine is adjacent, which is the horizontal.
Never mind, I don't know that.
No, that's fine, that's fine. You had it all. Okay? Everybody else good so far on those first two? Okay, now you gotta do the same thing for, okay, 3/12 is really pi fourths. Okay, and I'm gonna do sine of, this is my pi fourths right there. Sine is, oh yeah, same, 1 over square root of 2, just like cosine, because it's 1, 1. And here the last one right here is, oh yeah, this is the sine of, and really pi 6. So sine is square root of 3 over 2. All right, let's do the math. Then multiply, numerator times numerator, denominator times denominator. Numerator times numerator, denominator times denominator. We got common denominators, so we got 1 minus the square root of 3 all over 2 square roots of 2. Rationalize it. Right, that's what I rationalize. Remember that has to be distributed. Square root of 2 minus the square root of 6 all over 2 square roots of 4. Square root of 4 is 2. 2 times 2 is. But I'm doing it in radians. We've done all of that. You've practiced it all, the last 2 worksheets, the sum and difference rules, but I did it in radians. Okay, don't change them. Okay, just know that this little chart, okay, that I gave you right over here, okay, just know you have to convert it into the fractional amounts so you can see what you have to add and subtract. Any questions there on my first example? This is all still the stuff I didn't teach yesterday or for you guys Monday, just because I didn't want to confuse you too much with radians. Was that probably a good idea? I didn't confuse you guys with radians on Monday? It probably was. Okay. But today is not a day to you guys that are online to only half listen to me, because today is going to have a lot of math involved in it. Okay, because that's the sum and difference rules for sine and cosine that we know now. And I'm adding one more thing in there. I'm adding the tangent rule in there. And then I'm going to show you how to solve equations using all of these 6 rules. So that's what I said. It's going to be a day you're going to have to ask questions. Okay, don't sit back there and let me just keep on talking to myself if you're lost. Okay, the only thing that I'm not going to make you responsible for is the proof. Where did this rule come from? Okay, well, I think the first couple steps is pretty self-explanatory. Isn't tangent sine over cosine? Right? And this right here is the sine sum rule, and here's the cosine sum rule, and which gets us down to this right here. Now, if I would have taught you the cofunction rule, okay, and the odd-even rule, okay, there would have been a way to simplify this even further. All of this stuff, okay, does simplify down a little bit more. Okay, I simplify it to that right there, and then I simplify it all down even further to get something like this. And then I simplify it even further, and it gets to there. And after all that fun, and this is where I would have been smiling the whole time I get that final answer. I know you guys are disappointed because I didn't really explain how it simplified down, but make sure you write that down right now. That's the rule you got to remember in big. Tangent rule. Now, do remember that is one thing. If I split screen this right here, notice sine was on top and sine is the same. Notice if this is a plus right here, that's a plus right there because sine was on top. It was sine over cosine. And since sine was the same, I put a plus right here. And notice I'm just taking and adding them on the top and I'm multiplying them on the bottom. And if this right here is a plus, that right there is a minus. Because here's where things get really fun, and you get the smiles on your faces. Mr. Johnson says, oh yeah, what's the subtraction rule? What's the difference rule of cosine or tangents? What do you think it's going to be, Alyssa? Yeah, you guys said, she said, but all you guys are thinking, it's just flip the signs around. And all of you guys are just praying, please be that, please be that, because I could handle that. If it's anything else, I'm going back to bed. No, don't go back to bed, because I think she wins. Right? It was a minus here. It's a minus up on the top. But that's a plus down there. You got to remember, on the top, you add or subtract them. On the bottom, you multiply them. And since tangent was sine over cosine, sine was the same on the top, so whatever you're doing, if it's a difference problem, you subtract on the top. If it's a sum rule, you add on the top. But whatever you do on the top, whatever's on the bottom is the opposite. So, don't have to worry about all of that. Okay, the rule right up there, I know you guys are disappointed because I didn't really explain to you how everything simplifies all down. Okay, but the main part is, does everybody have all those 6 rules down? When I say 6 rules, okay, the one that I'm talking about is, you have those 4 down, plus the sum and difference of tangents. Okay, yes, I will give you a formula sheet on the test, but no, it is not going to help you get the test done in an efficient manner if you always have to look at the formulas. It's kind of like some of you, if you every time you do a math problem, you have to take 5 plus 7, enter. If you have to type in simple arithmetic into a calculator, your tests take you forever. You've got to be able to do some things up here in the head to be efficient. And knowing these formulas does allow you to become more efficient. Now, can you check and, if you're not for sure, just double check yourself? Sure. Okay, but you do need to practice them. So I guess that comes down to this. Let's use this rule. And I'm going to pick my favorite letter out there. Let's see. Pick a color, Alyssa. Purple. Purple B. Okay, who is my purple B? I thought that was Brady. It is. Okay, purple B. Okay, you get to answer this question, and all of us get to solve it using your method. Okay, how are you going to add or subtract numbers together to get 105?
Add 60 and 45.
Everybody always picks that one. Okay, I like it though. We'll go with that, Brady. 60 and 45. All right, so we got 60 plus 45. Now, do know there's lots of other ways you can get it. You can take up there and subtract, okay, from it. Okay, you can subtract your 135 minus 30. Okay, you can subtract, let's see here, there was a couple other ones they did. I think they took the 150 minus the 45. They subtracted there. For some reason, subtraction doesn't come as easily in our head as adding does. So that's always the one they first say. So, all right. Okay, you guys can go ahead and get working here. See if you can simplify that one. Okay, use the rule. And simplify. We're in degrees now too. So you should have a smile on your face. All right, so you got to at least know that. Okay, it's add or subtract the tangents on the top and multiply them on the bottom after you take one minus or plus that. Jameson, what are we going to have on the top? Is it going to be tangent of 60 plus 45, or is it going to be tangent of 60 minus 45 on the top? Mr. Jameson, you out there?
Add.
It's going to be add. I would agree. Remember, it's sine. Tangent is sine over cosine. And sine was always the same. Sine, same. So tangent, if we're adding, okay, the signs are the same there with tangent. Okay, so we have a plus on the top. We've got a minus on the bottom. All right. Now, this is where you've got to start getting better at things. Okay, you got to be able to say tangent of 60 degrees. Okay, what is it? Just spit it out. Okay, if you still have to draw, okay, your little picture, okay, just know when you guys get into calculus next year, okay, for those of you that are juniors, Ms. Rubis, okay, will not explain it by drawing the reference triangles. Most of your calculus teachers just say, okay, tangent of 60. Okay, what's tangent of 60 going to be? Oh yeah, that's okay, going to be the square root of 3 over 1. Okay, yes, that's 60 right here. That's 30, square root of 3 all over 1 right here. So we have the square root of 3 okay, right there. Tangent of 45. Tangent of 45 is 1 over 1. Then we have, after that, okay, 1 minus square root of 3 times 1. All right. Brady, you picked the nice way to do things. Okay, I wish I had what first hour. No, I don't have what first hour did. Okay, you should see what they have to do. And I'll pick a nasty way on the next one so you guys can see all about the Algebra 2 skills that you're forgetting. But you did a good job. Everybody's going to like you today. Okay? Maybe every day they like you though, Brady. Just to let you know. All right, denominator here, I got 1 minus the square root of 3. That's not my answer though. Why is that not my final answer?
You can't have the square root of 3 at the bottom.
You got it. Okay, you can't have radicals in the bottom. Okay, so, okay, we'll go with purple G. Gavin, how do I get rid of that square root of 3 in the bottom then?
You gotta times it by the top and the bottom.
Okay, what do you want to times on the top and the bottom by?
The square root of 3.
See, that's, again, I can read minds. I knew you guys were going to go there. Okay? And watch what happens when I do that. Okay? When I distribute this right here, I get the square root of 3 minus 3. The square root of 3 is still at the bottom. I mean, the top is the same thing. I'm going to get 3 plus the square root of 3. I don't care if it's in the top, but it's still right there in the bottom. So this is where all of a sudden, oh, I got all these algebra skills that I have remembered. I don't forget one of them. Can anybody help me out? Does anybody remember how to get rid of that radical in the denominator? You're going to knock me off my feet right now and say, Mr. Johnson, I remember this. And I had a great algebra 2 teacher. And you were a great student. Awkward silence. It starts with a C. Con. Get. Yeah, it's called the conjugate. We have to multiply, okay, right over here. So let me clean this up over here. It's not by the square root of 3. The only way that you can get rid of, okay, a sum or a difference of a radical in the denominator. If you have a binomial radical in the denominator, the only way to get rid of it, okay, is what we call the conjugate. What I mean by that is when you go back to algebra 1, here's an algebra 1 term. Watch what happens here when I multiply by its opposite right here. X plus 3, the opposite of it, it's kind of like the conjugate, okay, is x minus 3. Well, that's going to give us x squared minus 3x plus 3x minus 9. And why do I like that? Because those right there cancel out. And that's what I'm looking for, is how do I cancel something out of this? Well, how do I apply that to this problem right over here? I'm going to multiply by 1 plus the square root of 3. Now, I can't just do that on the bottom. I still got to multiply by a value of 1. I'm not changing, okay, the value of the fraction. I'm changing its appearance. So how does that make life for the bottom, the denominator? 1 times 1 is 1. 1 times positive square root of 3 is a positive square root of 3. Negative square root of 3 times 1 is negative square root of 3. Negative square root of 3 times a positive square root of 3 is a negative square root of 9, which really is 1 minus 3. So these square roots cancel out. That's what I was all looking for. And the whole denominator, when it's all said and done, simplifies down to negative 2. Oh, let's circle that. So this whole thing down here simplifies down to negative 2. So my denominator, okay, right here, when it's all said and done, I have negative 2 for my denominator. And that's what I was looking for. I can't have radicals in the denominator. Okay, you could ask me forever why, and I really don't have a really great answer for you besides the mathematicians way back when, okay, didn't have as fancy a calculators as we do now, so they just said, let's torment our students and say we got to rationalize the denominators. And that's what I'm going to stick to. I made that up, but it sounds cool. All right, numerator. I got to do the same thing here to the numerator. Square root of 3 times 1, square root of 3. Square root of 3 times square root of 3, we just did that. Square root of 9, which is 3. 1 times 1 is 1. 1 times square root of 3, square root of 3. So what do I get in the numerator? And I get an answer here of, well, those simplify together, that's 4. And these simplify together as 2 square roots of 3. Oh, would you say, Mr. Johnson, that still does not reduce all the way? I'm going to say you're right. It's not. Okay, why? because this numerator right up here, I can factor out a 2 out of this numerator. And why do I want to factor out a 2 out of this numerator? Because it can now cancel and I'm going to be left with 2 plus the square root of 3 all over -1. Or more put, -2 minus the square root of 3. Look at all that fun work. And you were, Brady, you're thinking, I chose the easy way? Yeah, you did. That's the easy way. No fractions were involved in this one. Alyssa has a look on her face. Mr. Johnson, I am excited to learn the hard way then. And I know the rest of you are looking at me the same way. No, you're not doing this. You're doing All right, here we go. What's the fun way? All right, let's try 285. All right, what can we add or what can we subtract? Let's do a subtraction one this time. How about if I subtract? I think we know how to do 315. Isn't that a 45-degree angle? And we can subtract 30 from it. Let's try, and there's lots of different ways to do this. Okay, you could have done an addition one right there and did a 240 plus 45. Okay, you could have done a 225 plus a 60. We could have done 300 and, well, not 345. We don't know how to do a 345. Could have done a couple other ones there. But anyway, let's just do this one. Okay, I'll get back to full speed. All right, go, have fun, see what you can get. Be like me right now and start working on this one and have a smile on your face the entire time. You know, aren't you guys like me when you're having a bad day, you just pull out math problems and start doing them? Is that yours yet? That doesn't work for you? I mean, that's what we do in our family. I mean, we got 2 math teachers. Mom's a math teacher, dad's a math teacher. So, you know, your daughter or your son's having a bad day, we just say, oh, let's get the flashcards out. And that just brings a smile to it now. Right? Remember, my son's a senior in college right now, and he had his mom for calculus, and she was the worst math teacher ever. No, it wasn't she was the worst math teacher ever. Okay? Son was the worst student ever. Always did things in his head when he was in Algebra 2, and then he got his butt kicked when he got to pre-calc and calculus, which was good for him. So Mom and Dad just smiled and helped him out and watched him call us the worst teachers ever. But he's doing good in college now. So you gotta grow up someday. You're still working even though I'm sitting here talking, telling stupid stories. But Brady's the one laughing at us right now because he's home from college and he's done with school. I know. So Dad sent him out working today. So I got rental properties that I have to have fixed. So I said, kid, you don't have a job yet? Here you go. I know, Dad is terrible. All right, so this is the difference rule. So we have difference, okay, of it. So we have to have, if it's a difference, okay, we know these are gonna be opposites. Okay, so difference, right up here, we have sine. Okay, right up there, which sine is on the top. So we have a difference, so sorry. That's gonna be a negative, that's gonna be negative right there. This tangent, we have the sign the same. We did a difference one, so they're the same up there. And then we have one minus tangent of 315 tangent. up there. All right. Now again, do you know what the tangent of 315 is without drawing the picture? To me, this is what you'll eventually, your calculus teacher would tell you. And this is what should go through your head. 315 is a 45-degree angle. Tangent of 45 is 1. But tangent is negative in quadrant 4. So this should be right here, -1.
Mr. Johnson,
Yes.
shouldn't the one on the bottom, or like, shouldn't that be plus tan 315?
Yep. You caught somebody out there not sleeping. Good job. I was just getting ahead of myself. Thank you for catching that. All right, so now I got the minus, I got the plus down there. Okay, I got tangent of 315. We know that's, again, 45 is 1, but 315 is negative in that quadrant. Okay, tangent of 30. You know that one off the top of your head. Well, this is looking at me like I'm crazy for knowing them off the top of my head. Okay, well, 30 degrees is right over here. We know the square root of 3 is there. 1, 2, tangent, okay, is going to be 1, okay, over the square root of 3. Okay, so, oh boy. Okay, this one's going to be fun. This one's going to have fractions in it. Okay, so now we have 1 plus -1 times 1 over the square root of 3. All right, so we simplify this. We have 1, -1 minus the square root of 3 over 1 minus, okay, 1 over the square root of 3. Now, I always have rules that just make me want to pull my hair out. Notice I have my hair still, so I don't pull my hair out very often. Okay, but what is one of the rules that wants me to pull my hair out? Here's the number 1 rule that I really drives me crazy. Okay, especially when pre-calc students do that. That one drives me nuts. Okay, but here's one that I get it. Okay, because it makes life look easier, but this problem is not an easy one. It's not as simple as, okay, doing this right there. No, it's not as easy as that. You can't cancel the 6's out and cancel the 2's out because that violates orders of operations. It violates the orders of operations because you guys all know this right up here is going to be 8 over 4, which is 2. So no, you can't come over here and do that. I know every one of you wants to do it. Okay? Now, what do you have to do? Well, we just have to come up here and okay, add them together. Okay, what do I mean by add them together? I'm going to take this and I'm going to make it the square root of 3 over the square root of 3. So that numerator right there comes out to be negative square root of 3 minus 1 all over the square root of 3. That's what the numerator, this numerator comes out to be. Because in order to add fractions, you need common denominators. Now note, yes, I got to get radicals out of the denominator, but please don't do it till your final answer. Why rationalize many times when the only thing that matters to the math gods is your final answer cannot have radicals in the denominator? Not right now do I need to worry about that square root of 3 being the denominator. Because actually, that square root of 3 is going to disappear here in a second if you do this the right way. So this is now the square root of 3 over the square root of 3, which this simplifies. So that we have square root of 3 minus 1 over the square root of 3. All right. We have a complex fraction. Algebra 2 lesson. How do you get rid of complex fractions? You multiply by the reciprocal in both the numerator and the denominator. Okay, that comes up to 8/5 over here. That's what that simplifies to. Okay, no, we don't have this problem right here. We have this issue of I got to get rid of this denominator here. But if I multiply by that same amount on the top and the bottom, yes, this all cancels out, and I'm left with 1 in the denominator. The nice part, this cancels with that right there. And all I'm left with then is, for an answer, you know, some of you are saying, all you're left with? Yeah, I know. And I'm left with my answer of negative square root of 3 minus 1, then all over square root of 3 minus 1. So here's my answer. Okay, this is basically this. All I've really done is got rid of the fractions. We are right back to where we did. And Brady, you're thinking right now, everybody, I'm your favorite student. Well, everybody's liking you really well because look at this. You did the shortcut, and this is the shortcut. You picked the right one that didn't have fractions. You could have picked a different one that had fractions, like the one I picked and made your life miserable on. Because right now and down to this part that Brady started off with, we now have to multiply by the conjugate. Square root of 3 plus 1 over square root of 3 plus 1. I know I lost many of you guys. You went back to bed 15 minutes ago. Okay, but I hope not, because this is the practice of these algebra 2 skills that you got to get better at. Square root of 3 times square root of 3 is 3. Square root of 3 times 1 is the square root of 3. 1 times square root of 3 is negative square root of 3. Negative 1 times positive 1 is negative 1. We did all of that so these radicals would cancel, and all I have left down here is 2. 3 minus 1. So, great thing is, I got a 2 in the denominator right now. Well, let's come up here with the numerator then. Negative square root of 3 times square root of 3 is negative 3. It's negative square root of 9. Negative square root of 9 is negative 3. Negative square root of 3 times 1 is negative square root of 3. Negative 1 times the negative one times the square root of 3 is another negative square root of 3. And negative 1 times positive 1 is negative 1. So unfortunately, the numerator does not simplify as nicely. We get negative 4 minus 2 square root of 3. Which simplifies after pulling out, okay, my 2 out of this. I got negative 2 minus the square root of 3 all over that 2 that's in the bottom, and those cancel. And my final answer, okay, is going to be negative 2 minus the square root of 3. Oh my goodness, look at that enjoyable time we just had. You think they're having as much fun as I am right now? I don't think they are either. You gotta kind of have something wrong with you if you're smiling at the end of this. And you know, you guys all know this whole year you've been with me, you know there's something wrong with me. Okay? Yeah, I love this stuff. Look at that. That's fun. And all right. But some of you love to read a book. And some of you are looking at me, what do you mean you don't like to read books? I don't know. When I sit down and I read a book, it just is not fun. I'd rather sit down and do these math problems. That's fun. So we all have our own strange methods. Any questions for you guys? All right. Now, there's all the fun there. Watch how we apply all this fun. Okay, we're going to apply all of this stuff by doing a solving equation problem. Now, can't read this. I'll make it a little bigger because I can see how that blew up. That says sine of 2 theta times cosine of 10 degrees minus cosine of 2 theta times sine of 10 degrees equals negative square root of 3 over 2. You should have remembered doing some of these problems, but they didn't look as fun as this. On the last class, I forgot to tell my class what I wanted my domain to be at. Okay, so when we're all said and done, theta has to be between 0 and 360 degrees. Okay, so I'll make my answers have to be between 0 and 360 because I know how much fun we're having. I'm not going to make it more difficult. So when you look at this problem right up here, this is where this little thing comes in right here, and I say, oh, is that one of those rules up there? What do you think? Ave, how you doing out there? Ave, you still with me? Did I put you back to bed? How long do you wait for someone to wake up? That's enough. All right. Okay, we will go to, Ashley, you're going to save your A friend over there, Ave, because he fell back asleep. Okay, do you recognize, in that problem, that being one of those rules, the sum of cosine, sum of sine rule? Does it look familiar?
Yes, it's the last one on the.
It's the last one. I love that you saw that. Okay, we see that this is a minus right there. We got a minus right there. It goes sine, cosine, cosine, sine, or sine, cosine, whatever you have right there. So this is going to be using the sine of A minus B rule. Okay, but in this case, right here, our A and our B, A is 2 theta. So this just simplifies to sine of A is 2 theta and B is 10. Look at how I shrunk that problem down. I mean, that's probably the first good news that you've seen on this whole period so far. I mean, shoot, I started out talking about radians. I mean, if that didn't make you cry, then I came over here and I did the sum and difference of tangent rules. If that didn't make you cry, then all of a sudden I did fractions within fractions and rationalizing fractions. So this has to be good news. So solving this, I want to get rid of the sign. And the opposite of a sine is an inverse sine. Whatever you do to one side, you do the same thing to the other side. These signs right here will cancel, and you're going to be left with 2 theta minus 10 degrees is going to equal, all right, what is it going to equal? First of all, where is sine negative at? Okay, if you had to look, Jennifer, if you had to tell me where sine is negative at, what quadrants is sine negative in? Miss Jennifer, are you out there? All right, it's nice to know some of you just turned me on. Ave, are you back yet? All right, how about Cecilia Meyer? Are you there? This is why online learning, I hate every minute of it. Okay?
I'll
It is-
go.
I know you guys will, and that's why I didn't come to you. I know there's a couple of them out there that I need to make sure they stay with me. Okay, and I got to make sure I just start counting them absent when they start doing this crap. Okay, go ahead, Annalise. What'd you say?
It's negative in 3 and 4.
It is. Thank you. Okay, so we have a negative. Sign is negative. In 3 and 4. So I'll draw my reference triangles. And again, you don't have to do your reference triangles, but I think we've done it all year long, and we're trying to think about, okay, in this black triangle right over here, that I have square root of 3, and it's vertical over terminal, so square root of 3 is negative 2. We have a negative 1 there. We know the 30s here, so that, yeah, nice that we're in radians or degrees, not radians. How far do I move around? And that's 180 plus 60, which is 240 degrees. So I have 240 degrees. But the most important part is what most of you leave off. There's something else that goes in this equation. Does anybody remember what needs to go in this equation still? Now it gets to this point, and then you could go around and you can get that point, and then you can go around again and around and again. What do I have to add to that equation? Anyone? Oh, Mr. Johnson, you said it. Yes, 360 degrees. Guys, remember, we have to put that 360 times n in there. Now, that's the first equation. That's right over here in quadrant 3. Okay, what about my one that's in quadrant? Okay, so that's one equation. I need the second one. So I want to get the second equation before I forget. Because some of you have been forgetting the second equation. And the second triangle, positive 1, negative square root of 3, 2. This is still a 60. But to get to that 60 right there, that is 360 minus 60, which is 300 degrees. So this is now, okay, same thing, 2 theta minus 10 degrees, but we have to have 300 plus 360 then. All right, any questions about those two equations? Those are called, okay, my general equations. Okay, but I need to simplify these general equations down, right here. Okay, I'm going to start here on this side and add 10. We get 2 theta equals 250 plus 360n. Divide by 2. Then theta comes out to be 125 degrees plus 180. Jameson, is Avi really out there, or is he just not answering? Jameson, are you not out there either? I know those two are friends. One could text the other one and say, hey, he's talking to us right now. All right, now I need my specific solutions. And my specific solution, I plug in 0, and I get 125 degrees. Plug in 1, 125 plus 180 times 1. Okay, that's going to give me 305. Okay, and if I go to 2, I get too far. Okay, that's gonna give me 485. And I said I wanted between 0 and 360, so that's too much. Now, if that wasn't enough, we're having so much fun. Okay, we gotta go over here and do the same thing here on this other side. Okay, add together. Okay, and we come up with here 2 theta equals 310. Divided by 2. Theta equals 105 plus 180 in. Right, and then we do the same thing down here. That n is 0. 105 plus 180 times 0. Probably don't have to show all that work, but I'm doing it just so you guys refresh your memory on what we did when we were doing these. And when n is 2, let's add another 180 onto this, and we get 465. And we know that 465 is too much. So answers. Okay, for theta are 125 degrees. We have 100. I divided wrong there, didn't I? Hope you guys realize it's not a 105, it's 55. I'm blaming it on I've lost focus because I keep on answering people and I keep on thinking about it. I'm sticking with that problem. And that's why I'm struggling right now. Probably not the answer, I'm just being dumb, but. I'm still thinking about how Abe's out there sleeping right now. Abe, you back? Now he doesn't want to answer. All right. Any questions there? All right. I'm not asking you how well you like this stuff because I know I'll get 1s and 2s. Okay, I'm asking you right now, how well did you follow along on today's lesson here so far and understand what I was doing? Scale of 1 to 5. Again, it's not about how well I like it because you're right. It's not fun. I still don't see Abe, Jennifer, and Jameson answering. Oh, Jennifer, you're there. All right, so I have 2 options. One, I can do another one of these solving equation problems, or you can start working on your homework. Okay, put in the chat right now which one you'd like me to do. Another problem, or start working on the homework. The homework is the 3rd worksheet. It looks like, okay, this right here. It says the sum and difference. Okay, identities 2 on the top of it. Okay, it looks like that right there. Okay, if you haven't finished up on, now you don't have to do the ones I crossed off. We'll go back and do those here later. Okay, but worksheet 1 and 2, those should be done minus the ones I crossed off. Okay, and then tonight's is the sum and difference, the 3rd worksheet, sum and difference of identities 2. Okay. All right, how about I do this? Okay, I don't have everybody answering me still. Another homework assignment. Okay, another problem or homework. Some of you want to do homework? Shoot, go ahead. Okay, you're more than welcome to do that. If you want to listen to me, okay, I will be more than welcome, okay, to do this problem right here for you. And that gives all of you right now 25 minutes to work on homework and get that assignment done. Okay, if you want to listen, listen. If you don't, okay, don't go back to bed, but you know, you can mute me. I don't care. Is there a way to mute people? Turn your speaker on? Yeah. Say things. Okay, so, all right, here we go. And so those of you that are following along, whoops, I got this is supposed to be a square root of pi 6. Okay, this one's actually not bad. It actually goes lots faster than that last one. And I noticed right away that this is the sum and difference rule of tangent. Okay, and plus is on the top. So I know right away, okay, that this problem is going to be the sum rule because it plus is on the top. This is a addition problem. So I have just simplified my problem tremendously down. And that's what all these identity rules are there for. Okay, you may not memorize them, but at least you'll know that, oh yeah, we did use them one time. So when you do get to calculus and you need to simplify, because calculus can get kind of sticky. That subject can get kind of tough. There's a lot of memorizing in calculus. At least if you memorize all that, that was a sum and difference rule. He talked about it, I just don't remember it from the end of the year. Okay, you can review it, use it, okay, in calc, and now we just gotta say, oh, I just gotta get rid of this tangent. So I'm gonna get rid of it by doing an inverse tangent. And that's gonna give us my first part. Okay, that cancels this out. X plus pi 6 is gonna equal. I don't know how many of you are still listening right here, but this is one thing that it has to go through your head. Tangent of -1. You've got to be able to do that by just thinking of it. First of all, tangent is negative in what quadrants? Well, all students take calculus 2 and 4. Okay? And I know -1 is a 45-degree angle. Well, 45 is really pi force. So pi force in quadrant 2 is really 3 pi force. So the visual to this is this. I'm over here, and I have 1, -1 squared root of 2. And yes, it's a 45-degree angle, but I have to make this pi force. And since this is 4 pi force, right, what do we come up with right over here? We have this is 3 pi force plus 2 pi. That's equation 1. And then you're thinking, oh yeah, it's also negative in quadrant 4. And pi force in quadrant 4 would be pi force shy of 8 pi force. So 8 pi force is really 7 pi force, or 8 pi force minus pi is, yep. If I have a pi force right here, that is 7 pi force of how far I go around. So my second equation, x plus pi 6 equals 7 pi force plus 2 pi n. Now the ugly part about this one is, yeah, it has fractions. But if you come over here and you subtract pi 6, that cancels out beautifully there. But 3 pi force minus pi 6. I know, I gotta get common denominators. Okay, so I come over here and I multiply. What would my denominator be? Okay, well, my denominator is gonna be 12ths. So I multiply this one by 3 over 3, which is 9 pi 12ths. I multiply this one by 2 over 2, which is minus 2 pi 12ths. So my answer right here is x equals 7 pi 12ths plus 2 pi n. Only thing good that comes out of this, besides, learning how to do fractions, the only one that's going to be between 0 and 360 is the first one, n and 0. So 7 pi 12ths. Because if I did n as 1, I'm gonna have to add on another 12 pi 12ths, or sorry, 24 pi 12ths onto this, and that's gonna come out to give us 31 pi 12ths, and that's more than 2 pi. So that one's out. So there's my answer, 7 pi 12ths for equation 1. Equation 2. Same thing. Now multiply this one by 3/3, which is 21 pi 4ths, or 12ths. Multiply this one again by 2/2 minus 2 pi 12ths. My equation, so I put two part, that's equals 19 pi 12ths plus 2 pi. Then the only one that's going to be between 0 and 2 pi is when n is 0. And the two answers for x are 7 pi 12ths and 19 pi 12ths. All right, for those of you that are listening, is there any questions that I did on any of those steps that you may have had? I know the toughest part about the end of the year is one, oh, sorry, Elena, go ahead.
Oh, I was just gonna say, like, I was listening. I don't have any questions, but for the in radians, is it like, so it's like pi over 2, and then it's pi, and then is it 3 pi over 2, and then 2 pi?
For the quadrantals, yes.
Yeah, okay. I was just making sure.
You got it, yep. And one of the things I was going to conclude about is the end of the year is tough two ways. One, we all want to check out early. I'm the same way. I'm ready for summer too. Okay. And two, we always summarize the end of the year because we're always using everything that we've learned. Not only what we've learned this year, but what we've learned in the past years. And that makes it really tough for students because one, they've checked out. Two, when things get hard because they didn't understand or remember things from the past, it's easy just to, oh, I'm just going to forget about this. I'm not going to do the work. It's getting hard. So it's better to just not do and fail than to do it and struggle through it. Because I might fail. I don't know if you understand that. Okay, not something I've ever accepted very well because effort has always got me through everything. Okay, if I'm going to fail, at least I'm going to go down trying. And that's what I hope you guys get out of this. And the end of the year is not going to be terrible. Okay, just go down. If you're going to go down, holler at me and I'll help you before you sink. Okay, but you icons, okay, you got to say something to me. Okay, if you're having troubles. Okay, let me know if you need to come in for help. All right, work time here. Okay, we still have 15 minutes of work time. I can answer any question. Past homework, this homework, whatever it may be.
Yeah, it's so painful. Just like staying. But in the park, sometimes sometimes I come in for Iowa assessments when I'm still on Iowa assessments. And then I can't recall.
I get it. So you just have let's this semester. We start. All right, you guys have a good day. Let me know if you guys have any questions on things. I'm here to help you out.